In this question, we have a wire that has a mass per unit length 0.04 kilogram per meter. So this wire is suspended on two cables and is hanging on these two cables. The whole thing is in the magnetic field with the direction of the magnetic field pointing into the board. The magnitude of the magnetic field is 3.6 Tesla. The question is, what should be the magnitude of the current flowing in this wire and in what direction it should be flowing so that there is no tension in these two cables. So these two cables experience no tension. Well, let's think about this. When will this happen? When will the two cables experience no tension? This will happen when the gravity force, which is the weight of that cable, is balanced by another force, which in this case has to be the magnetic force, F magnetic. So when these two forces balance each other, there will be no tension in the supporting cables. Well, this means that the first expression we can say is that the magnitude of Fb, the magnetic force acting on the wire, has to be balanced by the weight of the cable. Now, we know that in order for the force to be pointing upwards, the direction of the current has to be going to the right. Let's check that. Using the right hand rule, index finger is pointing along the direction of the current, middle finger is pointing into the board, and so F is up. So if the current is flowing in this direction, then the force will be pointing up. Now we also know that the current has to be flowing in this direction because of the way the EMF is set up. So it goes from a higher potential to a lower potential like this. So that's the direction of the current. Well, we know that from the picture that the current is perpendicular to the magnetic field. So current is going to the right, magnetic field is into the board, which means that they are perpendicular. So the angle between them is 90 degrees, which means that FB is simply equal to ILB times sine pi over 2, which is 1. So this has to be equal to mg. From here we can calculate for current. So current is then equal to mg over LB. Sine pi over 2 is just 1. And now let's look at this m over L. This is the mass per unit length, which is given to us. And g over B. So this is mass per unit length, m over L, 0.04 kilogram per meter. And we can use that here. So this is then equal to 0.04 kilogram per meter times 9.1 meter per second squared over the magnetic field, which is 3.60. So the current is then equal to 0.109 amperes.